when the system is already at equilibrium, the stress which has been applied, the equilibrium will be get shifted. So, according to the Lee-Chatterley's principle, it states that the system has to nullify the stress. When the temperature of the system is increased at equilibrium, the system tends to decrease the temperature by the adsorption of the heat so that endothermic reaction will be favored. When the above system is heated, the decomposition of the N2O2 is favored and the equilibrium will be shift towards the left. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with a unit called equilibrium. Under this unit, we have discussed about the derivation for a Kp expression for the gases which undergo reversible homogeneous reaction, and also we have learned that how to make a relationship between the Kp with the Kc, and also we have learned about the applications of equilibrium constant, and also we have learned the relationship between the equilibrium constant as well as with the reaction coefficient as well as with the Gibbs free energy. Today, let us move on to understand what are the factors which are really going to affect for the equilibrium. Okay. So, when we are dealing with the factors which are affecting to the equilibria, we need to understand the law which has been given by the Lee-Chatterley's. So, first we will see what is the Lee-Chatterley's principle says, then how many factors are there to affect the equilibrium. Let us understand now. Okay. The Lee-Chatterley's principle states that when external stress is applied onto the system at dynamic equilibrium, the system shifts the position of the equilibrium so as to nullify the effect of stress. So here the Lee-Chatterley's principle states that when a system is at equilibrium, suppose if you are taking a system, you say the system is at equilibrium. Now I'll change the temperature, I'll change the pressure either by increasing or decreasing. Similarly, I can also increase the temperature or I can decrease the temperature, or sometime I'll add more reactant or else I'll add my product also. Sometime by adding the catalyst also, we can put the stress onto the system. When I supply the stress onto the system, we know that the system is already in the equilibrium state. What will happen? The equilibrium will be get disturbed. When the equilibrium get disturbed, what are the Lee-Chatterley's principle states that? It states that the equilibrium of the system has to nullify the effect of stress. Whatever the stress which has comes externally to the system, the system has to nullify the stress. How do it nullify it? It has to be nullified just by shifting its equilibrium. So, this idea was given by whom? Lee-Chatterley's. So, what does its statement says? According to it, when a system is at equilibrium, when you apply the external stress in the form of increasing the concentration, in the form of increasing the pressure, either by adding a catalyst, either by adding the reactant or product, when you apply the stress onto the system has to nullify the effect. To nullify this effect of stress, it will shift its equilibrium. So, that effect we call it as what? Lee-Chatterley's principle. We'll take up the first stress, that is effect of concentration change. If I change the concentration of the reactant or to the product, we'll see how does the equilibrium will get shifted. Okay. When the reactants are added to the system at equilibrium, the system tends to decrease the concentration of the reactant that has been converted into product. Thereby, what will happen to the equilibrium shift? It has to be shifted towards the forward direction. So, the forward reaction will be favorable and the equilibrium will be shift towards the right side. I can take for this by taking an example of A plus B is giving rise to C plus D. Okay. Now, we know that these two are the reactant. Correct now? And these two are my product. Now we have understood that the system is at equilibrium. I am going to apply the stress in the form of taking the reactant concentration more now. Okay. Now I add more reactant to the system. What will happen? We know that the reactant, if I add more, it has to convert it into product. So that the system will change its equilibrium from left sides to right side. Thereby, it favors the forward reaction. It favors what? Forward reaction when you apply the higher concentration of the reactant to the system. So, how does the equilibrium get shifted? Because when you added the reactant to the system, obviously the system will get disturbed, so that the reactant will react themselves and it will form a product. So that the equilibrium will be shifted forward direction. Now, when the product is removed, okay, from the system at equilibrium, the system tends to increases the concentration of the product by converting the reactant into product, so that the forward reaction is favorable and equilibrium will be shift towards the right side. Now what will I'll do? I'll remove this product formation. So whatever the product which has been formed, I'll remove it. What will happen? The system has to nullify the stress. So that what it will do? It will do the conversion of the reactant has to form a product. So what it will do? It will quickly allow the reactant to form a product, so that again the reactions which are favored in a forward direction, so that equilibrium shift will be existed. This is how the change in concentration of stress, when it is applied to the system, there is a shift in the equilibrium will be observed. We'll take up the example for this to understand the effect of concentration change. Okay. Let us consider the hydrogen and iodine and hydrogen iodide in a closed vessel or in the closed container at a constant temperature. Now, if you see that my hydrogen and iodine, these two are my reactant which are combined together to form a 2 hydrogen iodide. Correct, no? Now, what I'll do, if hydrogen is added to the reaction mixture, only I am taking the reactant 1, that is hydrogen. If I add more to the equilibrated system, now I am adding what? Reactant H2 more to the system when the system is already at equilibrium. What will happen? When the system is already at equilibrium, the stress which has been applied, the equilibrium will be get shifted. So, according to the Lee-Chatterley's principle, it states that the system has to nullify the stress. Correct, no? So, here what will happen? We'll see how the reactions will be favors the forward or the backward reaction. Okay. When the equilibrium of the reaction is disturbed, in order to restore it, the reaction proceeds in a direction where hydrogen is consumed and more hydrogen and iodine is reacted to form a hydrogen iodide. Finally, the equilibrium will be shifted in right side, that is, it favors the forward direction. You can see that if I add more hydrogen iodide now, the equilibrium will be get disturbed. In order to nullify this effect, what does the system will do? The system allow this excess of the hydrogen to react with the remaining iodine to form a hydrogen iodide. So that reactions which are going in a forward direction, hence the forward directions will be favored in order to shift its equilibrium. Suppose now I add the more product. What will happen? We'll see now. If I add a more product, we know that the product will again decomposes back. It will be decomposes back, correct, no? And give rise to the H2 and I2 respectively. So that the reactions which is coming backward, thereby it will nullify the effect of the product, the effect of concentration of the product. This is how, the forward and the backward reactions or the directions will be favored by a system in order to nullify the effect of stress. Okay. So, when you increase the concentration of the reactant, it favors the forward direction. Suppose when you increase the product concentration, so it will favors the backward direction, so that the reactions will come in a backward direction. A portion of added hydrogen iodide decomposes to give a hydrogen and iodine which attains a new equilibrium. Okay. This is how, the concentration change can be observed in a Le-Chatelier's principle. This is the first effect. Let us see what is another stress effect, that is the effect of temperature, okay, or effect of change in temperature. When the temperature of the system is increased at equilibrium, the system tends to decrease the temperature by the adsorption of the heat, so that endothermic reaction will be favored. So, if you increase the temperature, so what will happen? Adsorption of heat will be taking place in the system. Reactions will be favored in the endothermic way. Endothermic direction, that is in the forward direction. Suppose if I decrease the temperature, what will happen? So, it involves the evolution of heat. So, when the temperature of the system is decreased, the system will be tends to increase the temperature by the liberation of heat, which is nothing but an evolution of heat. So that it favors the exothermic reaction. It favors what? Exothermic reactions will be favored. So, how can we understand the effect of change in temperature? When you increase the temperature of the system, what will happen? The absorption of the heat has to be taken by the system, so that endothermic reactions will be favored by the system in order to nullify the effect of temperature. Suppose if I decrease the temperature of the system has to nullify this effect, so that it involves in an evolution of heat. Thereby, it favors the exothermic reaction. So, this is how the effect of the change in temperature can be understood based upon the Le-Chatelier's principle. We will take up an example so that you will understand this effect. The effect of temperature on the equilibrium can be demonstrated by taking the NO2 gas, which is a brown in color, that is nitrogen dioxide gas, which is brown in color, which dimerizes to give N2O2, which is a colorless gas. Which is what? Colorless gas. We are taking the nitrogen dioxide, which dimerizes, which means to say that the two molecules which are behaving like a single molecule, that we call it as dimerizes. Okay. So, here the two molecules of nitrogen dioxide which will be undergo dimerization and forms a N2O2, and which is a colorless. You can see that this is a exothermic reaction because the change in enthalpy we have indicated with a negative sign. It is a exothermic reaction. We have taken a condition where the nitrogen dioxide will be dimerized to give a N2O2 and the reactions which is in a exothermic way. Now, in this equilibrium, forward reaction is a exothermic and the backward reaction is endothermic. So, the backward reactions will be endothermic, forward reactions will be exothermic, as I have indicated with the negative sign. Now, I will consider the effect of change in the temperature. When the temperature is increased, to oppose the increase in temperature, the system will be favors the endothermic reaction. So, what does it do? When I increase the temperature of the system, increase the temperature of the system. So, we know that in the forward direction, it is a exothermic. So, heat is liberating. In order to nullify this effect, the system will be moves in a endothermic way in order to nullify this effect. So that the system will be moved in a endothermic reaction. Okay. So it is a endothermic. Now, therefore, when the above system is heated, the decomposition of the N2O2 is favored and the equilibrium will be shift towards the left. So, what will happen when you increase the temperature? The N2O4 which undergo decomposition and give rise to the 2NO2. It is a backward reaction and it is an endothermic in nature. Okay. Now, when you decrease the temperature, what will happen? It opposes the decreasing in the temperature of the system so that exothermic reactions will be favored. So, when the above system is cooled, the dimerization of the NO2 is favored and the equilibrium will be shifted towards the right. What will happen? When you decrease the temperature, the two molecules of NO2 gas is moving in a forward direction so that it forms a N2O4 which is a forward reaction and it is an exothermic reaction. This is how the system will nullify the effect of temperature when you increase or decrease, thereby it shifts its equilibrium. Now, let us see what is the effect of change in pressure. It is another effect. Okay. If the pressure of the system is increased at equilibrium, the system will be tends to decreases the pressure by decreasing the number of moles. What does it say? If you increase the pressure, the system will be decreases the number of moles. Okay. Suppose if you decrease the pressure, it makes a increase in a number of moles in the system. This is a general one that you need to be understand. So, when you are applying the pressure at equilibrium state to the system, suppose if you are increasing the pressure of that system, what will happen? The number of moles in that system will be started decreasing. Suppose when you are decreasing the temperature to that system, again equilibrium will be get disturbed so that there will be increased number of moles will be absorbed in that system. Okay. If the pressure of the system is decreased at equilibrium, the system will be tends to increase the pressure by increasing the number of moles so that equilibrium will be shifted towards the side, shifted to such side. So, what does the statement says? Suppose when you are decreasing in the pressure of the system has to nullify this effect, thereby it has to increase the pressure of the system to maintain or to nullify that effect. So, what does it will do? It will increase the number of moles in the system. So, thereby it will nullify the effect. You can see that the carbon monoxide is going to react with an hydrogen, thereby forming a methane with a water molecule. This is the best example for this. You can see that in a reactant side I have only the 4 moles of carbon 1 and 3 moles of hydrogen. They reacted themselves, so the 4 moles will be involved. Whereas in the product side, again I have only 2 moles of the product. Correct now? Now what will happen? We'll see now. Okay. When a pressure is increased, as I have understood, when a pressure is increased, the number of moles of the reactant will be, number of moles of the product will be get decreased. When a pressure is decreased, number of moles of the reactant or the product will be get increased. That is the one thing that we have already understood. Let's take up an example with this above equation. So, what will happen if I increase or decrease in a pressure? We'll see now. When a pressure is increased, the volume will be decreases and it favors the reaction in which decrease in the number of moles. What will happen when you can see that when I apply the higher pressure to this system, what will happen? It will decreases the number of moles. Why? Because when increase in the temperature, increase in the pressure decreases the number of moles. In this way, when you increasing in the pressure to this system which is already at equilibrium, it will decreases the formation of number of moles. Okay, number of moles, so that it is favoring in a forward direction. So the reactions will be moves in a forward way. Okay. Suppose if I decrease the temperature, what will happen? If I decrease the pressure of the system, what will happen? When the pressure is decreased, it favors the backward reaction and equilibrium will be shifted towards the right side. You can see that when I decrease the pressure to this system, this entire reactant, it is giving rise to the product because it undergo decomposition process. Thereby, number of moles will be get increased. This is how, the effect of pressure on the equilibrium or to the system can be easily understand. Okay. Next we have the effect of catalyst. Usually the catalyst have no effect on the position of the equilibrium because it alters both the forward reaction as well as with the backward reaction in the same extent, but equilibrium will be attained quickly. That is why we can say that the catalyst has no effect on the equilibrium. But we can understand the effect of some of the rare gases. We'll see now. The addition of the inert gases or the rare gases at constant volume does not change the partial pressure or the molar concentration of the substance involved in the reaction, so that the added gas does not take part in the reaction. Therefore, the addition of the inert gas has no effect on the position of the equilibrium at constant volume. This is another thing I like to add. If you add any inert gases to the reaction, it does not have any effect, as we have learned in case of the catalyst. Now, I'll take up an example. Okay. In that, let us understand how does the effect of pressure, how does the temperature, and how does the concentration will affect to the particular reaction. My reaction is nitrogen is reacting with an hydrogen to form an ammonia. So, how many moles will be involved in the reactant side? Again, there are 4 moles of the reactants are involved to give a 2 moles of the product. That is, the 4 moles of the nitrogen and hydrogen reacting themselves to form a 2 moles of the ammonia. Let us understand for this reaction what is the effect of temperature, pressure as well as with the concentration. First, I will go with the effect of pressure. The increase in the pressure increases the rate of the forward reaction, so that it is accompanied by decrease in a number of gaseous molecules. You can see that if I increase the pressure, okay, if I increase the pressure, what will happen? The nitrogen and hydrogen, okay, they reacted themselves to form a ammonia. Okay, ammonia. You can see that when I increase the pressure, okay, the reactants are going to react themselves and forming a ammonia, so that 4 moles of the reactant are going to become very less and forming a 2 moles of the product. So when I increase the pressure at the product side, you can see that there is a decreasing in the number of product which has been found. So the reactions which are favoring in a forward direction. Now what I'll do, I'll decrease the pressure now. Okay, I'll decrease the pressure. What will happen? If I decrease the pressure, the reactions will be favors the backward direction, so that the ammonia will be decomposed to give a nitrogen and hydrogen. So again, what will happen? Number of moles will be get increased when you decrease the pressure. This is how what actually I said in the effect of pressure. When you increase the pressure, number of moles will be get decreases. When you decrease the pressure, number of moles will be get increased. So in this reaction, if I increase the pressure, my products are become very, very less. Now, if I decrease the pressure, the product itself will undergo decomposition and give rise to the more number of reactants. You can see with the numbers. So 4 is giving rise to 2 and 2 is giving rise to 4. Now we see the effect of concentration. The increase in the concentration of the reactant increases the forward reaction. The addition of ammonia decreases in the concentration of the reactant increases the rate of backward reaction. So what I means, if I increases the concentration of the reactant, if I increase the concentration of the reactant so that it will form a product, it will favors in a forward direction. It favors in a forward direction. Okay. Now, if I increase the concentration of the product, if I increase the concentration of the product, the reactions will be favored in the backward direction. Backward direction. So, this is an effect of concentration. Last, we will see the effect of temperature. The increase in the temperature increases the rate of endothermic reaction, that is a backward reaction, and decrease in the temperature increases the rate of exothermic reaction, and it is a forward reaction. So, what it will do, if I increase the temperature, so it will become what? Endothermic, and which is nothing but a backward. Okay. If I decrease the temperature, so it favors the exothermic reaction. Okay. And the reaction which is favor the forward. So, this is how we can understand the effect of temperature, concentration as well as the pressure on a particular reaction. So, hope you are understood with the factors which are affecting to the equilibrium just by understanding the Lee-Chatterley's principle. In our next class, we are going to understand more about the ionic equilibrium. So, by this, I like to say that what are all the things which I covered in this session, it is very important for your competitive exam as well as your board exam. So, have a look on it. We'll meet you with the next session. Till that, take care, be safe. Thank you.